Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Along with engineering drawing, you can find other interesting topics as well here. Do subscribe the channel to get alerts. If you like this lecture, please hit the like button. That will keep me motivated to do many such videos in the future. Now let's jump into the topic. Here we'll see the line inclined to both the planes. So here a straight line making angle with both the reference planes look like this. It's making angle with both the HP as well as VP. In the front view or in the top view, we cannot see the true length of the line because it is not parallel to any of the reference planes. So here, if you see the actual front view, it appears like this, shorter than its original length, and it appears to be making some angle with HP. And in the top view, it appears to be something, right? It's less than its true length. So here, if you draw the projections of the line, final projections appear like this. So let's see how to draw it. So let's take the problem here. A straight line AB, 100 mm long, has one of its end 10 position is given, and it's making some angle with the HP and VP. This is here the true length and true inclinations of the line are given. And we have to find the final projections. The final projections are A dash, B dash, and AB, and also the apparent angles. Let us see how it is. So this is the data given. Let's represent the data. Take the reference line. A is 10 mm above HP. 10 mm above HP, we have drawn a line. And I marked a point here. Right? This is A dash. And 15 mm in front of VP. At 15 mm distance, we have drawn another line and marked the point here. A and A dash will be lying on the same projector, perpendicular line to the reference line. So this is about point A. Now, let's see the angle with the HP. It is making some angle, say theta with the HP. Here, to get the final projections of the line, we take the line, we consider line in two initial positions, and slowly we come to the final projection. So first initial position we consider is parallel to the vertical plane. When it is parallel to the vertical plane in the front view, we see the true length of the line, that is 100 mm, and the actual inclination with the horizontal plane, that is theta. So maybe 30 degrees here. So A dash, B dash, B1 dash, because we call it as first initial position, because this is not the final position. Why? Because the line is making angle with both the planes. But here we are considering the line parallel to VP and making angle only with HP. That's why this is not the final position. We call it as first initial position. Of course, A is fixed, but B is not. That's why we call it as B1 dash. So this is the true length of the line, 100 mm, and the actual inclination 30 degrees is this one. Now, let's draw the top view of this, right? And when it is lying, when it is making an angle 30 degrees with the HP, the point B will be at certain height above the horizontal plane. And this height is fixed because when you increase the angle, then only the point B will be moving at a higher position. Or when you decrease the angle, the point B comes down. When you maintain this angle constant 30 degrees with the HP, the point B will be at the same fixed distance, right? Point B may be somewhere here or anywhere on this line. That's why we call this point as B1, the locus of B in the front view. Next, let's draw the top view for this, right? B1 dash and B1 will be lying on the same projector. And because it is parallel to the vertical plane and of course 15 mm in front of VP passing through A. So A B1 is the top view and here is the A dash B1 dash is the front view. So this is the first initial position and we make two observations here for this line. When it is making an angle 30 degrees with the HP, we get some length in the top view that is less than its true length, and this AB1 is fixed. There won't be any change until and unless there is a change in the angle with HB. That's why the length of the top view is AB1. Second observation is, when it is making an angle 30 degrees theta with the horizontal plane, the point B will be at this height only. When it is at this height, the angle is fixed. So we call this line, which is drawn at a height of passing through B1 at this height above horizon reference line, we call it as locus of B in the front view. These are two observations in the first initial position. Now let's consider the line in the second initial position, that is the line parallel to the horizontal plane and making angle 45 degrees with the VP. Okay, now let's consider when it is parallel to horizontal plane, we see the true length in the top view. So we consider this as second initial position and we call it as AB2. AB2 is the top view of the line. Here we see this actual inclination 45 degrees with the vertical plane, and also we see the true length of the line in the top view, actual length 100 mm. When it is making an angle 45 degrees with the VP in the top view, the point B, we are calling it as second initial position. That's why it is B2. So the point B will be at a fixed distance in front of VP from the reference line. Okay. So if you draw a line passing through B2, we call this as the locus of B in the top view. So this is B2. Now we draw the front view for this, draw projectors, and because it is parallel to horizontal plane, passing through A dash, draw a line horizontally. This intersection point is B2 dash. Here again, we make two observations. They are, the line when it is making angle with the vertical plane, right, some 45 degrees here, its true length is not seen in the front view. And the true length is fixed. How far? Until and unless you change the angle with VP, there won't be any change in the front view. So when you are maintaining this 45 degrees, the front view length is fixed and it is A dash, B2 dash. In the top view, the point B will be at this distance in front of VP. That is the locus of, if you draw a line here, this is called the locus of B in the top view. Now, let's take that first initial position here. So say AB1, we know the length of the top view. AB1 is the length of this line and then it is seen from the top, and AB1 is the top view line. A as center, AB1 as radius. If you draw a line, right, an arc, if you draw an arc here, how far? Until it reaches the locus of B in the top view. Why up to this locus only? Yes. When it is making, when the line is actually parallel to VP, it is making 0 degrees angle with VP. When you are moving this point B away from VP, it slowly makes more angle with 0, 1 degree, 2 degrees like this. When point B is moving like this, it is making more angle with the vertical plane. And we know that when this point B is at this locus, it is making this 5 or 45 degrees with the VP. So that's why we rotate this point B until it reaches the locus of B in the top view. When it reaches the locus, this is the final position of the point B, right? Final end position, point B. Join AB, right, by a straight line, and you can highlight it because it is the final projection of the line in the top view. Now, we can do one more thing. We know the length of the line in the front view, A dash, B2 dash, and A dash as center, A dash, B2 dash as radius. you can rotate the line like this, B2 dash moving upwards and starts making angle with the HP also. So A dash as center, A dash B2 dash as radius. You can draw an arc in the front view until it reaches the locus in the front view. That's when the intersection of this arc and this line gives you the point B in the front view, final position. That is B dash. You can do that. And once you get it, join this point B dash and B. You will be these two must be on the same projector. That's a check. So here, otherwise, you need not even draw this arc and all these things, because we know that B and B dash lies on the same projector and A dash B2 dash is radius. If you draw an arc, right, it exactly intersects here at this point. That's why no need to draw this arc and all. You can directly draw a projector from B and onto this locus. This point, intersection point, is nothing but B dash. Join A dash B dash by a line. This is the final front view and this is the final top view. So that's what we are asked to find. We have to draw the final projections of the line in the front view and top view. And here, if you observe, this is the front view and it appears to be making, the line appears to be making alpha angle, which is more than this theta or 30 degrees. More than this 30 degrees angle in the front view. Why? Right? Actually, what is the angle of this line in the with the HP? It is making theta or 30 degrees only with the HP. How do you say that? Because the point B is at this height, right? The line will be making only theta angle, but it appears to be making alpha in the front view. Okay, so because it is appearing and more angle with the horizontal plane, it is appearing only. That's why we call it as apparent angle in the front view, alpha. And coming to the top view, even this is also making a 45 degrees angle or phi with VP. But here it appears to be making more angle with vertical plane. It is only appearing to our eyes, but actually it is making a 45 degrees angle only. How do you say that? The point A is fixed and B is at this locus only, on this locus. When it is on this locus, it is making 45 degrees angle only with the VP. So this angle is called beta. So these alpha and beta are apparent angles and theta and phi are true inclinations or actual inclinations. Okay. So with this, we have finished drawing the final projections of the line and marking all the angles. Okay. So in the next coming videos, we are going to see more problems on this line inclined to both the planes. Hope you had understood this topic very well. And if you have any queries, any questions or comments, do comment. Thank you.